This is HRW96P012 or 012, sorry. Okay, this is the one about the guy from Philadelphia. So this guy suspended himself from a rafter by gripping the rafter with the thumb of each hand on one side and the fingers on the other side. Sinkoski's mass was 79 kilograms. If the coefficient of static friction between the hand and rafter was 0.73, your number will be different. What was the least magnitude of the normal force on the rafter from each thumb or opposite fingers? Okay, so this is actually a lot easier than you might think. First off, let's figure out how much weight he needs to hold up. So how much, what's the force of gravity on him? So you got mass times gravity. So that's 79 kilograms times 9.8 meters per second squared. Basically, his weight is 774.2 newtons. Okay, that's how much he has to hold up. But what they're saying is that is being held up by the friction between his thumb and his fingers on both hands. So it's being held up by basically 4 points. So each point needs to hold up a fourth of that. So we're going to divide it by 4. And then we get 193.55 newtons. Okay. Notice I'm not rounding right now because you don't round until the end to avoid errors. Okay, so that's how much needs to be held up with each point, and that is being held up simply by the friction between like the pad of his thumb or whatever and the rafter. So that's my friction, okay, for each point. Okay, so my friction for each point is 193.55 newtons. Friction is mu times the normal force. So to get the normal force, I just divide by mu, which for you, everybody's is different, but mine is where is it? 0.73. So I get 193.55 divided by 0.73, which to me is 265 newtons. Whoops. Okay. 265 newtons, which is in fact the correct answer on my problem. So that's it. We're done.